Hello everyone, this is the continuation from the Bohr's atomic model. From the idea of this atomic energy, we will now go to a topic what we call as a spectra. So there are three types of spectra that we will be looking into. Number one will be the continuous spectra. Secondly will be the emission, followed by thirdly absorption spectra. And for this video, I'm looking at the second and the third spectra because I will have another one video to talk more about the continuous spectra. So we'll start off with the emission spectra. So this is one example of a spectra that if you have a white light and you pass through the prism will split the light. So a white light here, if you split it, your background here, this is where you get your series of the rainbow color. Moving on. Emission, how do we generate emission spectra? This is one example of the hydrogen emission spectra that we looked into previously. So how do you do it is that this procedure is pretty simple. You take a glass jar here that contains only pure hydrogen gas and you pass an electrical discharge through it. Yeah, so this electrical discharge will excite the gas. So after the gas is excited, it will begin to glow. Yeah, the glow means that in excited state, you know that this atom cannot remain in that state for a long time. It will descend to the ground state, and in that process will emit light, it will emit radiation. So to put it like this, a summary, take a gas jar containing hydrogen, excite to give it an energy to put the atoms in excited state. When the atom de-excite, you release photon that when you pass through the prism, this is where you will get the four distinctive color lines here that I've shown previously. So this is, remember, emission, you have a few bright lines on an otherwise dark background. So this is emission. From a dark background, you have emission of several distinctive lines. So this is for hydrogen. Okay, and you can read about this. This intensity can change here. Intensity, how bright the lines can change by changing the amount of hydrogen in the jar. However, one thing that you need to know is that those four colors, the wavelength emit is the same. So this is what we call that is unique. Okay, unique to the element. It is a fingerprint to the element. Yeah, the intensity can change. However, the strength of this color, the wavelength of those color remain the same. So this is a way to use to identify the types of element present in any sample. So to give you more idea, this would be the so-called unique. For example, the first one, helium, you shall see all these colors are being present. Intensity can change, however, these are the wavelength being produced. It can be very bright or dim, however, you will see 1, 2, 3, 4, 5, 6 or 7 visible lights. For mercury, this will be the picture, this is the fingerprint. Same goes for krypton and oxygen, they have their own fingerprint that you cannot duplicate. And lastly, uranium, a very heavy element, heaviest of all. In terms of natural element, you have a lot of lines. So this one, I think we can demonstrate to you in the laboratory, because we have some discharge tube that when you pass through the diffraction grating, you can see this with your own eyes. So this is emission spectra. And I shall move on to absorption spectra. Okay, so how do you produce it? This is the fastest way. So how do you produce it? First of all, you must have this in fluorescence lamp. Fluorescence lamp, you pass through the gas. Yeah, you pass through the gas here, and then let the light here pass through the prism. If you do so, what you have is that you have this rainbow color, but a few dark lines. Okay, why do you have the dark lines? It's because this energy being reabsorbed by the cool gas. So like in this case, I can take this as a hydrogen gas. The fluorescence lamp will give you a white light, which means it will give you a full spectrum of the light. However, certain of this white light is absorbed by the hydrogen gas here. So that's why when it absorbs, you will have these dark lines. So this is what we call absorption. The white light, some of the energy being absorbed by the element. Again, by looking at the dark lines here, you will know what kind of element you have as your cool gas. Alright, and moving on, this is the lines that we get from our sunlight here. So we have a lot of dark lines because you can see that our atmosphere, we have a lot of elements here that we can identify clearly. What do we have? Okay, oxygen, nitrogen, everything. You can see by your when you analyze this. And this absorption line for our sunlight, it has a special name. It's called Fraunhofer lines. That's a special name. So to tell you more about that, more example, absorption spectra is also unique. Yeah, unique because no two elements will have the same absorption lines. You cannot find that. You cannot duplicate that. So these are sample hydrogen, helium, lithium, and beryllium, the first 4 elements. Alright, and also I can tell you also one more feature is that the absorption and emission both will occupy the same wavelength. Okay, the reason of it, perhaps you can think for a moment, why is that so? We shall discuss that more in the class. Okay, so as I said, if you match these lines, for example, I have one sample here, what kind of element present in the gas? I can tell you for sure helium will be present because when you match it, you will have these lines here. So this is a spectral analysis. So all this you can read by your own. Nothing much else I can tell you besides the production of this emission and absorption lines. So we shall discuss more about that in the class. Thank you.